Welcome to Group 15 Showcase Demo. Our project is SecureScape.
All right, and so a little bit of an introduction to the group and our project. SecureScape is a smart portable security system designed to detect motion, classify threats, and then provide alerts in remote areas where you don't have access to the internet or Wi-Fi. And so I myself am Jackson Topol on the left here, and then we have Colin Kirby, Philip Morano, and Dylan Myers, and we are two computer engineers and two electrical engineers.
Our group identified a gap in the market for affordable outdoor security systems. We developed a smart security system designed to operate in remote locations without Wi-Fi or cellular service. Our goals are to create two different devices, namely the Node and the Gadget. The Node is a smart monitoring device which features a camera, LEDs, and a buzzer. The Gadget will stay with the user at all times and acts as a remote and central hub for SecureScape.
Alright, so just to give more context regarding our project, this is the overarching setup, starting out with our gadget in the middle, the ESP32S3. It serves as the central hub for notifications as it's where the micro router is held. This can trigger the peripherals as a node, and it also acts as the medium for communication between the mobile app and the node, which can also trigger more of the peripherals. And then the node is where most of our active outputs are held, with the alarm and the light. And it's also where motion is detected through the PIR, and then images are captured with the ESP32 cam, then sending messages over the HTTP to the gadget, and then that being seen by the mobile app to then trigger the notifications.
This slide will focus on the Node's parts and peripherals. The Node PCB is mounted in the center section of our 3D printout. Our design will allow the LED strip to wrap around the top of the node. Our passive IR sensor will be seated in a forward-facing position so that it may pick up on movement easier. The last peripheral on the node is the buzzer, which will be placed on the backside of the rectangular section. Atop the node is our power bank, where we can easily facilitate powering the PCB and also have our wiring done internally for a more professional appearance.
For the gadget in the housing, the bottom of the housing holds the battery and the Wi-Fi router. The mid layer will hold both PCB boards and connective wiring, and the top layer will house the buttons.
This next section of our demo, we will be going through the overall functionality of our system. We will be demoing person detection and response, mobile app control, and then gadget control.
So this slide really breaks down the core workflow behind our entire project. So it works when motion is detected by our passive IR sensor. The ESP32 cam will then snap a picture and then immediately process this using our onboard edge impulse model. If that detects a person, it will then trigger the alarm and lights and then send a notification to the mobile app. The communication for this is happening over our HTTP server. It's all real-time and self-contained. We found this setup to be really fast and reliable, and it really forms the backbone of how our system responds to potential intruders. And then just make a movement. And hopefully it comes back. There we go. This test shows how we interact with our system through the SecureScape mobile app. When the user taps a button, whether to restart the system, turn on the alarm, or toggle the lights, that command is then sent to our central gadget over HTTP. The gadget then forwards it to the node, which performs the requested action. The app even gives you feedback once the command goes through. In the demo that follows, you'll notice some error messages. Those are not really true error messages, but just instead timeout responses from the delay of our HTTP server. As you'll see in the video, everything functions as intended with minimal delay. Just a heads up, the next couple of tests do use the buzzer sound, which can be pretty loud and kind of piercing, so we recommend lowering your volume in advance. This test focused on using the SecureScape gadget directly. So when a switch is flipped on the gadget, it'll instantly send a command to the correct node, no app required. From this, the node will then carry out the action, like toggling the alarm or the lights, and again, as you'll notice in this demo, there's some slightly noticeable delay within the triggers. This again goes back to our HTTP server introducing some extra responsiveness and lag into our calls. However, everything still functioned as intended as in the video.
Alarm on.
I would say schematic just for your PCBs.
Alarm off.
So like even those ones too.
Are they on the schematic?
Lights on.
Well, because like it would be like the whole schematic. Of the button.
Lights off.
Not just the schematic of the button. So like if the schematic of the button is on, your schematic is tied to different things.
Should work. It's just the way.
Okay, there we go.
Now getting into our engineering specs demo.
In the following slides, we will be demonstrating our system's detection accuracy, response time, and detection range. To detect accurately and for fast response times, we need reliable communication across our devices. Detection range is mainly a hardware limitation of the passive IR sensor, but even when movement is detected, our system must reliably react within a minimum of 5 feet away.
So like it responds well. It's just.
The main purpose of these tests is really just to verify full functionality of our complete system from start to finish, from motion detection to our app notification, with different test subjects, as you'll see in the following clips.
Well, yeah, that's still fine, but
Okay.
keep it. Hopefully it picks up. Yeah. Just trying to move it back. Hopefully. And then just like making movement. And hopefully it comes back. There we go.
This test is measuring the response time of our system, from motion detection to the receival of the notification. To get a more reflective timing of real-world scenarios, we're starting the timer when the person detected flag clears as shown by the all clear on the top of the screen, and stopping when the alert fully covers the dashboard.
Just hoping that. There we go. And then just like making movement. And hopefully it comes back. There we go.
To test our detection range, we started at a distance where the node couldn't detect the person and slowly moved closer until a detection notification was received on the phone, as well as a slight beep you can hear from our alarm in the videos. Since detection was consistently accurate around 15 feet, we extended our testing range to approximately 25 feet to better evaluate its limits.
Oh.
It's detecting me anyway.
Is this recording from?
Okay.
Thank you for tuning in to our Senior Design Showcase demo.